This recording is going to be CCNA 2, Chapter 6, VLANs. Gonna be a bit tougher chapter than the previous couple. We've got, I don't know, somewhere around 60-ish slides, and there are multiple concepts to understand in this chapter. Again, probably the hardest chapter we've had in a little bit. So what I'm going to do is split this up into two separate videos, and in class we'll discuss this in sections. We'll go through the first section on VLANs and trunking. How do you set them up? What do they do? Then we'll have a final section on inter-VLAN routing, where, well, a router comes into play. So we're going to split it up along with our labs. We'll do some labs for the first section and kind of complete that as its own segment, and then we'll go on to the next section. So as we move along. So what are VLANs? We've used VLANs, or a VLAN before I should say, just for managing the switch. We're going to use VLANs now to segment our network, which does increase security and has multiple benefits. We're going to talk about how those VLANs communicate with each other, how switches handle carrying a VLAN or VLAN tags from switch to switch, then how do we talk between VLANs. Okay, so that's probably the hardest part is 6.3. So we'll get through 6.1 and 6.2 in this video. Alright, so VLAN segmentation. We discussed broadcast domains in chapter 5, I think, or 4, one of the two. But anyway, we saw that having a large broadcast domain, well, it can slow down your network. Okay, and the more switches you have connected together, the larger your broadcast domain would be. So for instance, if we have this PC over here and it sends out a broadcast, it's going to go to, well, every PC here through the switch to these PCs, to the switch, and to those PCs. Okay, that takes up a lot of traffic. All these PCs have to process that frame. The switch has to send the frame forward and make a frame forwarding decision, so it's just kind of wasting processing power and your network bandwidth. In order to alleviate that, we create VLANs. So VLANs, if you have them created, when you send a broadcast, it's only going to be sent to that VLAN in which your device resides. Okay, so for instance, if you have VLAN 2, this guy sends a broadcast, it only goes to these PCs on VLAN 2. Same thing with VLAN 3 and VLAN 4. Okay, so that reduces your broadcast domain. You also don't have the ability to communicate with VLAN 3 or VLAN 4, which you might want to set up for security purposes, or so people aren't looking into files they shouldn't be looking into. Okay, so there's multiple reasons for VLANs, but it's basically segmenting your network, creating a virtual LAN. It's like its own network segment, or its own subnet almost. Okay, if you think of it that way. It's like a layer 2 subnet. In fact, the way you set up VLANs is that you do put each VLAN in its own subnet of your network. So for instance, you can see the IP addresses of these VLANs down here. Okay, so that's a best practice, and we'll set that up in just a minute. So here on this slide, we have a couple things that I just discussed on the last slide as to what VLANs do and what their reason for existing is. So they allow an administrator to segment networks based on whatever factors he wants, basically, whether it's team, project, application, function, whatever. In that individual VLAN, as you have things separated, okay, you can apply security policies to certain VLANs. You can kind of just manage the VLAN on its own, whereas you'd have to manage all these devices if you didn't have VLANs in existence. So I can apply a certain security policies to VLAN 2 versus VLAN 3 versus VLAN 4. Okay, it is a logical partition of a layer 2 network, so it is splitting up your layer 2 network into sections that really can't communicate with each other and are their own basic network. Multiple partitions can be created, multiple VLANs can exist. We talked about the broadcast domain. Each VLAN is its own broadcast domain. Okay. They are mutually isolated, and again, they cannot pass packets between them. Only through a router can VLANs communicate with each other. So if you've got a bunch of switches here, if these VLANs wanted to communicate with each other, VLAN 2 would have to send a packet out down to the router would spit it back up, and then it would finally go to VLAN 3 or VLAN 4. So that's the only way VLANs can communicate with each other, is by passing a frame or packet down to the router, and the router redirecting it. Takes place inside of a layer 2 device. Yes, it does. We'll talk about VLAN tagging and how the switch sees that in a minute. Hosts group within a VLAN are unaware of the VLAN's existence. So the VLAN's not set up on your host device. The VLAN's all set up on the switch. So yeah, your host has no idea it's in a VLAN because it's all managed inside of your switches. Okay, there's no VLAN setup on your end devices. Some of the benefits of VLANs, we've already discussed a couple of them. You have improved security. For instance, you wouldn't want faculty resources to be on the same network as student resources necessarily, so you have those separated from each other. Reduced costs. If you did want these all to be on separate networks, you really would have to put routers in between them if you didn't have VLANs, if you wanted to isolate them from each other. So it does reduce the cost of having to add other devices to your network. Better performance in smaller broadcast domains somewhat goes hand in hand because, well, having a smaller broadcast domain does result in better performance. There's less broadcasts being sent out. Less information being processed by end devices, by your switches. So that's going to give you better performance, and well, that the smaller broadcast domains do give you better performance. IT efficiency, you're going to be able to manage those VLANs as you see fit. So you can manage users with the same network requirements on the same VLAN. Okay, so you can just implement those policies and assign someone to a VLAN. And that kind of goes along with management efficiency and simpler project and application management. Just the ability to set up the VLAN, again, as you see fit, and then assign different end users to the VLANs based on their needs. Okay, so those are your benefits to a VLAN. So we have different types of VLANs. You've got data VLAN, which just is a normal VLAN that you'd have a device on to send traffic. These VLANs here, VLAN 10, 20, 30, those are all data VLANs. Your default VLAN is VLAN 1. That's the VLAN that everything starts out in until you, well, put in another VLAN or you create another VLAN. Okay. Native VLAN, I guess we can discuss right now. It's for untagged traffic, if it were to be passed from switch to switch. Okay, you are going to put your host devices in some VLAN if you decide to set up VLANs, which you should. If you have untagged traffic that doesn't belong in any of these VLANs or isn't tagged as VLAN 2, VLAN 3 or VLAN 4, that traffic would travel over a native VLAN that we set up. Okay, I'll discuss that more when we get to trunk ports and where the native VLAN comes into play. Management VLAN, that is the VLAN that we've been setting up for Telnet and SSH. Interface VLAN 1 is what we've been using. We'll be using, well, different VLAN numbers for that because it's not a best practice to have your management VLAN be the same as your default VLAN. Okay, so we will be, well, any VLAN that you set up and you give an IP address to is your management VLAN. We are going to name those VLANs so they are easier to identify when you do a show VLAN command on your router. So we'll have, well, all these types of VLANs set up. All right. So your default VLAN, if we do a show VLAN brief, it'll show you the VLANs that are available and which ports are in which VLAN. Whoops, didn't mean to do that. Okay, you've got some reserved VLANs for token ring and fiber optic connections. So basically, the easy way to remember it is if you just use VLAN 1 through VLAN 999, then you're in the clear. If for some reason you need more than 1,000 VLANs, then, well, you can only go up to 1,001, but easier way to remember it is 1 through 999. Okay, those are the VLANs that are available for us to use. Wait a minute, going back real quick. So just these bullet points down here, all ports are assigned to VLAN 1 by default. That's where they end up by default unless you move them yourself. Native VLAN is VLAN 1 also by default. Management VLAN is also VLAN 1 by default. Hence, it is the default VLAN. Okay, so remember that. Could come up as test questions. I mean, default VLAN is default for everything. Okay, except for fiber optic and token ring down here. Voice VLANs weren't listed in that list of VLANs. It is a specific type of data traffic. It's its own type of traffic because it has special needs. It needs assured bandwidth for voice quality. You don't want to have your voice calls dropping out or being interrupted by network congestion. So it does need priority on your network. It needs to be there needs to be less than 150 milliseconds of delay when using voice over IP. So that VLAN will need that set up, and there are special things you'll need to do to make sure your network is ready for voice over IP. But we don't do that in this course. But we do need to know the concept that your voice VLAN is its own VLAN. Okay, it's just not going to be on the same VLAN as your PC here, VLAN 20. You'd have your own separate VLAN set up for your voice traffic. So here's an overview of things I pretty much just stated on the last slide, that the voice over IP needs certain requirements, assured bandwidth, priority, ability to be routed around congested areas, delay of less than 150 milliseconds across the network. So again, we don't set that up in this class, but you will in a future class if you decide to pursue your Cisco network engineering career. I think that's a CCNP topic, so we don't see it here. So the voice VLAN feature enables access ports to carry IP voice traffic from the IP phone. Okay, we're going to talk about access ports versus trunk ports now. So, trunk ports versus access ports. We've last chapter, when we were configuring port security, we had to do switch port mode access to turn your switch port into an access port rather than an automatic port. And basically what that means is an access port can only carry one VLAN, and your access ports are going to be set up for any switch port that connects to a host device. Okay, so it's only carrying one VLAN at a time. Trunk ports allow traffic from multiple VLANs to be carried from that port to another. So for instance, from switch to switch, you're going to need to set up a trunk port that will send multiple VLANs from one switch to another. Okay, because for instance, we have VLAN 10, 20, 30, all connected to switch 2. Switch 2 needs to be able to send traffic from all those VLANs up to switch 1, so switch 1 can send it back down to switch 3. And in order to do that, you set up the port from switch 2 to switch 1 as a trunk port that can carry multiple VLANs. Okay, you can see that it's set up to carry VLANs 20, 10, 10, 20, I'm sorry, 30, and VLAN 99. Okay, VLAN 99 they have set up here as a native VLAN, which is a VLAN that carries any untagged traffic from switch to switch, because there is some untagged traffic that will be sent that isn't assigned to any VLAN from switch to switch. Okay, and we'll talk about that native VLAN a little bit more as we move along here, but that's what trunks are. Trunks are set up to be able to send multiple VLAN traffic over a single port. Okay. So some more specifics about your trunk. Again, kind of restating what we just discussed, is that a trunk is a point-to-point link that carries more than one VLAN. Okay, it's a way to send multiple VLANs between switches. So we saw this in the previous slide too. It's a setup between switches, so switches with the same VLANs on each one can communicate with each other. You have VLAN 10 on one switch and VLAN 10 on another. They need to be able to communicate through those switches. So that's what the trunk is going to allow them to do. Send multiple VLAN traffic from switch to switch. A trunk by itself is not associated with any VLAN. It's just carrying multiple VLAN traffic. So you're not going to say that that port is in VLAN 20 or something like that. You'll just have to label the VLANs that you want that trunk port to carry. Also, you're going to need to give it a native VLAN. Okay, again, that's something we'll discuss a bit later. It is very important to assure that your trunk ports on each side, so S1 and S2, are set up the same in which VLANs they are going to carry traffic from, as well as their native VLANs. That's where you can start getting some errors. In fact, if you set up a native VLAN on one end that doesn't match the other, you'll get error messages like every 5 seconds, and it gets pretty annoying. So you'll know if you set that up incorrectly. So here we just have an example of how the VLANs will help control broadcasts. So without VLANs, if PC1 sends a broadcast, it's going to go to PC2, it's going to go to PC3, PC4, PC5, and PC6, because it goes and, well, spreads throughout the entire local network. Okay. With VLANs, what happens? Well, the switch is only going to send that broadcast out ports that are configured with VLAN 10. Okay, so this is a VLAN 20 port. Nope, not going to go that way. But this broadcast gets sent out. There's a trunk port here for VLAN 10. Okay, that goes between switches. Again, trunk ports go between switches to carry multiple VLANs. It's going to go down here, and then this access port is assigned to VLAN 10 as well. So you've reduced traffic on your network, hopefully making your network a little bit faster, and also you've provided an extra layer of security. You don't have all devices receiving broadcasts, and you have basically your VLANs isolated from each other. So what does this slide say? Basically that all traffic is limited to within your VLAN. The broadcast, your multicast, your unicast, you cannot go outside your VLAN unless there's a router involved, okay, which we'll see in inter-VLAN routing. So all this stuff, each VLAN is its own broadcast domain, is true. It limits the reach of broadcasts. It's only going to be sent to devices within that VLAN. Controls the reach of broadcast frames and their impact on your network, and unicast and multicast frames are forwarded only within the originating VLAN. So again, VLANs can only communicate within that single VLAN or devices associated with that VLAN unless there's a router involved. Okay, so know those bullet points for VLANs. Possible test questions. All right, tagging Ethernet frames for VLAN identification. Basically, that VLAN data that you set up needs to be added to the frame. So your switch adds the VLAN data to the frame and then decides where that frame needs to go, okay, based on that VLAN tag. So we'll just talk about it here then, or the bullet points here, then we'll take a better look at it in the next couple slides. So it is the process of adding VLAN identification to the header, this frame tagging. It's used to properly transmit VLAN frames through our trunks. Okay. Basically, your trunks have the ability to allow or deny different VLAN traffic through them based on what you've allowed through your setup of that trunk on your switch, which you'll see in the second portion of this chapter. The switches do the VLAN tagging. So when you have a port on a, let's say, VLAN 10, and some traffic comes into that port, your switch is the device, of course, that slaps that VLAN tag on. Okay, remember, this switch is doing this work. It's not your end device saying I'm on VLAN 1 or VLAN 10 and encapsulating that in the frame before it sends it to the switch. The switch is the device that's doing all this VLAN tagging. There's different protocols, but the one we'll see in this chapter is 802.1q. I believe the old protocol was SLC, if I'm not mistaken, but the one we're going to be using is this one. It defines the structure of your tagging header, which we'll see in the next slide. These VLAN tags are added to the frames before placing them onto your trunk links and removed before forwarding them through non-trunk ports or access ports. Okay, and when they're properly tagged, which is of course what we'll be setting up, proper tagging, they can go through any number of switches before reaching the correct VLAN at the destination. So this is something we'll see as we go through our labs, and as we it'll be explained a little bit more as we go through our slides here. Okay, so again, VLAN tagging is done by the switch before the frame is sent through a trunk link. So here's that VLAN tag broken down. You've got a type, which is basically what type of traffic is it. For instance, this is Ethernet, a 0 times 8100. Okay, priority, what's quality of service do you have? What level of priority does it have? Okay. This is not really used that much, but it's for token ring. It enables token ring frames to be carried over Ethernet links. And this last part, the important part, is your VLAN ID. Okay, 12-bit VLAN ID just carries whichever VLAN your traffic belongs to. So your native VLAN is set up as kind of a catch-all for anything untagged on your network. Okay, so if you have a network where there's data that doesn't belong to any VLAN, pretty much untagged, doesn't have this, let me go back up, doesn't have this tag field in it, which is going to be pretty unusual actually, then it's going to go over this native VLAN, okay, which does need to be set up on your trunk. When we set up a trunk, one of the first commands you're going to enter in is which native VLAN do you want to use for that trunk. And if you have two switches connected together, they're going to need to use the same native VLAN. Okay, so this is for when you receive untagged traffic. They're placed on this native VLAN, then forwarded. All right. You should not have any other ports associated with that native VLAN. For instance, an access port that's connected to an end device. If it's the same port as your native VLAN, your trunk is not going to send it through. Okay, so if you have VLAN, we'll say 10, as your native VLAN, and you also have a PC on a port configured for VLAN 10, when that traffic hits the trunk, it's going to drop it because that port matches the native VLAN. It's not supposed to match. It's only supposed to be for untagged traffic. Hopefully that makes sense. Let me see if I have a graphical representation. So, for instance, if I have this port here, okay, in VLAN 10 we'll say, and the native VLAN here from switch 2 to switch 1 is VLAN 10. That is not going to be communicated because you have an access port in the same VLAN as your native VLAN. The native VLAN should be unique to the trunk. It should be set up both on switch 2 and switch 1 as the native VLAN, VLAN 10. And it's only for untagged traffic. If you have some other device on VLAN 10, it's not going to be able to be sent through this link. Okay, so just make sure you understand that. If there's no other port associated with the native VLAN, so your trunk port doesn't have another trunk port connected to it associated with the native VLAN, that traffic, any end tag traffic I should say, would be dropped. So you need to have that native VLAN configured on both ends of the trunk. Okay, otherwise it will be dropped. Again, this is the concept I was just talking about. Do not configure your devices on the same VLAN as the native VLAN. That is not something that you do. Only your trunks, okay, that are connected to each other will have the same native VLAN. Your other access ports will not. Okay, the default VLAN for the native VLAN is VLAN 1, which is not a best practice. You want to move that native VLAN to some other VLAN, as long as it's off 1. 1 is the default VLAN, and you'll learn later on that there is certain traffic that travels over VLAN 1 that you don't, and for that reason, you don't want to have your native VLAN on the same VLAN as your default, which is VLAN 1. Okay. So here we have voice over VLAN tagging, which is a little unique in that we just discussed trunk ports that carry more than one VLAN. But a unique situation that you can have is you can configure an access port to support both voice and data VLANs without being a trunk port. Basically being able to carry both a voice VLAN voice VLAN and a normal data VLAN. You actually have a PC over here that you can't see. So this port FA18 on the switch is an access port, and it's going to be able to receive data from two VLANs, this voice VLAN and VLAN 20 over here that will be attached to the PC. Now it will give this voice VLAN 150 more priority, okay, because it is set up as a voice VLAN. It'll tell it how it wants to encapsulate. Switch 3 will instruct the device on how it wants it to encapsulate its voice traffic so that it does get priority, and VLAN 20 will just be set up normally. We'll go over, I believe, those commands in the next section. If we don't see them, I think we do. Actually, we do not. We just need to know the concept that that you can have a voice VLAN and a normal data VLAN connected to the same access port here. Okay, so this is a concept to understand. The last part here we have an example of how your broadcast would be sent when you have multiple VLANs set up. I think we've already gone over this, that each VLAN will only receive broadcasts within the VLAN. Okay, so that's all we have there. And that's it for this section. So we've introduced the concepts of VLANs, trunk ports versus access ports, a little bit on voice VLAN tagging, or just VLAN tagging in general, I should say, and how voice is treated differently with priority and whatnot. We are now going to go into the configuration of your VLANs. So we've talked about the concept, configuration is next. And here we go, VLAN implementation. So, getting right into it, a couple concepts here. The VLANs that we will be using are the normal range VLANs as we set things up in class. You also have extended range VLANs, not LAMs, that will be stored to your running config rather than your VLAN.dat file. Okay. So your VLAN.dat file is in flash memory, and if you kind of want to totally reset your switch, you'd have to get rid of that VLAN.dat as well as the startup config. Then you'd be back to square one. But our normal range is from 1 to 1005. Our extended range is from 1006 to 4096. And if you remember a couple slides ago, in fact in this slide here, you see there are some IDs that are reserved for token ring and fiber optic or fiber distribution data. Okay, they're automatically created and cannot be removed. All right, VTP, VLAN Trunking Protocol, does not learn extended range VLANs. So our normal ranges, you can see these are the reserved ones that were just mentioned on the previous slide, and by default you have one default VLAN. This is what you will see if you just do a show VLAN brief without configuring anything. Okay, so every port is in the default VLAN, VLAN 1. And you have these other VLANs that are created for us automatically. Here we have the commands for creating a VLAN, which is pretty easy. You've got configure terminal, go to global config, type in the VLAN ID you want to create. In this case, they use VLAN 20. What do you want to name it? That name is going to be pretty important in keeping things organized because your names will show up over here, letting you know what you named the VLAN. Okay, so if you have your VLAN segmented logically, like by student, faculty, guests, or by division of your company, that name is going to be pretty important. It is recommended that you create your VLANs before you start assigning VLANs to ports. You can create a VLAN right as you assign a port to one, but then you won't have the name and things can get confusing. Alright, so assigning ports to VLANs. Once you've created it, then you just go ahead to the interface. If you're an end device and you're not trunking, you're going to go to switch port mode access. Okay, and then switch port access VLAN yada yada, in this case 20, and that will assign that port to said VLAN. If you did this without creating the VLAN first, this would actually create the VLAN for you, but you wouldn't have a name or anything for it. So it is best to create the VLAN first. Okay. Once you've done that, you've got, well, it's already has you changing the VLAN. So before this change was made, interface F018 would have shown up out to the right of this student VLAN that we created in VLAN 20. Alright, if you want to remove it from that VLAN, you can go no switch port access VLAN, and that will remove it from whichever VLAN you assigned it to and place it back in the default VLAN. Okay, if you also switch VLANs there, it'll if you go switch port access VLAN something else, it'll switch the VLAN that it's in if you want to switch it to some different VLAN. So there's how you'd remove it, and if you want to switch it, just switch port access and then the VLAN you want to move it to. Okay. And so here it is in VLAN 1, the show interfaces, and if you want to switch to another VLAN, like I said, just switch port access, whatever VLAN you want to move to. In this case, they moved Fast Ethernet 011 to VLAN 20, and here it is in VLAN 20. Okay. This is going to be pretty mind-blowing, but if you want to delete a VLAN, you type no VLAN in the VLAN you want to get rid of. Yes, it works. It's unbelievable. Down here, if you want to delete all of your VLANs that you created, you can do a delete flash :VLAN.dat. That's going to get rid of all of your VLANs from privileged exec. If you have your VLAN stored in the normal flash location, you can also just do delete space VLAN.dat, and that should do it as well. Okay. Nothing else to see here, folks. Let's move along. Here you just have a couple show commands, but to be honest with you, show VLAN brief is probably fine for just about everything you'll need to do. It'll show you your VLAN ID, which ports are in that VLAN. So that's really all we'll need in class. So show VLAN brief is great. We've done our show interfaces. If you want to do a show interfaces switch port, that'll show you some VLAN information as well. For instance, that's what we saw on our previous slide. Show interfaces, some interface switch port. It shows you your mode, which is access, if you're trunking or not, which VLAN you're in. So yeah, that's all. Also a good command. All right, anything else there? If you want to see interface VLAN this or that, you can type in that VLAN. And a couple examples. So show VLAN name student, you can do it by name. Okay, you'll get information showing interfaces, VLAN, some number. So we've just basically got here that the VLAN is up and active. Okay. Now here's how you're going to configure your trunk. And your trunk should be the same on both ends from switch to switch. So we'll probably discuss this in class, but if you know you're going to be setting up the same commands on multiple devices, it is advisable just to open up a notepad file, type in those commands, and you can just copy and paste those commands from device to device, which is probably what you'll end up doing in the future a lot, using that notepad to type in your commands, copy and paste. Even if you go into your running config, you can copy commands and paste them into a different device. So that's something we'll over in class. Anyhow, to sort of set up your trunk, you've got configure, terminal, of course, go to your interface. Switch port mode instead of access, we go to trunk. You've got to set up a native VLAN, get it off of VLAN 1. So any other VLAN will do, just make sure the native VLANs match on both switches that you're trunking to. And then your allowed VLANs. Okay, if you don't do switch port trunk allowed, everything will be allowed. By doing this command, just those VLANs will be allowed, and don't forget your native VLAN over here. Everything else will be disallowed. Okay, that's what this command does. If you don't do this command, every VLAN will be allowed across the trunk. Okay. So we have an example here. This trunk would be configured the same on both ends with the native VLANs and the VLANs that you're allowing. Everything else, well, anyhow, not much else here to see. Each VLAN should be in its own subnet. Okay? Each VLAN you can see here is in its own subnet. That's the way you design it. If you don't want to be a trunk anymore, then no switch port trunk allowed VLAN will get rid of all the disallowed VLANs, and no switch port trunk native VLAN will get rid of that native VLAN and set that back to default. You could also go switch port mode access to switch from trunk to access. That's an option as well. But this would just reset your trunk values. Okay, you would still be in a trunk mode at this point. You just reset your allowed and you reset your native. Just about every command, if you want to reverse it, you just type no in front of it, then the command that you entered in. That should basically wipe it out. Alright, so your best practice here, you're going to clear out all of your trunk parameters that you entered in first, and then if you want to switch to access, you'd go and reset back to access. Okay. And here's just verification of your trunk. If you went ahead and made an interface a trunk, giving it a native VLAN of 99, then you went to do your show interfaces yada yada switch port. You can see that you're in trunk mode. Encapsulation.1q is on. We don't have to type that anymore, which is nice. You used to have to type encapsulation.1q. Anyway, native VLAN 99, trunking VLANs enabled, all because we did not do that allowed command that we saw a couple of slides back. So again, if you don't do that allowed command, every VLAN will be allowed across the trunk. So I mentioned this before. It is highly advised and common practice that each VLAN is associated with its own subnet or network. Okay, otherwise you're going to run into issues. So you might as well just think of it that it has to be, because that's the way we're going to set it up. Okay, I guess you can do it without, but you will run into issues. So for instance, this IP address 172.72 is not in the same network as 172.17. which is what the other devices in the VLAN are in. Okay, and you're going to have trouble communicating if that's the case. So this should be 172.17.10.21. Then we wouldn't have any issues. Okay, so you want to have your VLANs within the same subnet or network. All right. So here we have some troubleshooting. If you still can't communicate and your IP addressing is not the issue, then maybe you're in the wrong VLAN. If you are in the wrong VLAN, you can do a show VLAN to see that, and you can assign your port to the right VLAN. If you are in the right VLAN, is the VLAN in the database? If it's not, then you can do your show VLAN, by the way, or show interfaces to see that. If it's not in the database, then well, you can go ahead and create it, and you should be okay. So usually just doing a show VLAN here will tell you everything. It'll show you if the VLAN's there. It'll let you know which VLAN the port is in, and you should be okay from there. But you can also do a show interfaces to make sure the the VLAN's there in the database as well. Okay. So here's something that can get people in trouble is if you have a port in a VLAN, okay, you have a port in a VLAN that gets deleted, then your port is basically going to be unable to communicate with anything. It belongs to a VLAN that no longer exists. So if you do a show VLAN brief, you won't see that port anywhere in the show VLAN brief. So what you're going to need to do is bring back that VLAN with the original value that it had before to get your port to be visible again. Then you can move your port from one VLAN to another, do whatever you need to do with it. Okay. Otherwise, your port won't be able to communicate if you delete it. If you delete the VLAN that it's in without moving it. Okay. Alright, with our troubleshooting trunks, I've stated before, and it's important that you have the same native VLAN on both ends of the trunk. Okay. You also are going to want to make sure you have the same VLANs being communicated across the trunk. We don't change the encapsulation, but if it's not 802.1q across both trunks, you'll also run into errors, which is what this problem over here is referring to. So we've got to make sure that everything matches, basically. It's somewhat, yeah, what we've discussed before, just making sure on each end of your trunk that everything matches. So summing it up, your problems with your trunks usually are native VLAN mismatches, your trunk mode, 802.1q or whatever mismatches, or you might have one port in trunk mode, one port in access mode. All right, that is going to cause you problems as well. Your allowed VLANs on the trunks, so you have that also. So more problems with trunks. If you don't have a VLAN match, you have a mismatch. There can be a security risk because traffic can now get across potentially your trunk that's unintended to. Okay, you're also going to have error messages sent very frequently if you are configuring the switch, so it's going to get very annoying very quickly. If you have trunk mode mismatches, okay, if you have one end as a switch port and an access port and one end as a trunk port, that can give you problems. When they're talking about dynamic auto, there's modes called dynamic auto and dynamic desirable. If you have a port configured to be a trunk but the other end's not set up as dynamic desirable or a normal trunk port, then the trunk will never be formed. That goes outside of our materials here, but there are dynamic modes that will automatically configure a trunk. If they're not set up correctly, then the trunk will never be created. And are the allowed VLANs on the trunk correct? Essentially, we have down here. Whoops, too far. Okay, here we are. So here's an example of an incorrect mode. On S3, we have an access port. On S1, we have the trunk set up, but there's no trunk on the other end. So you're not going to be able to send that VLAN 10 traffic across. Okay? You've got a mismatch. So you cannot communicate. Alright, so you need to switch this from an access port to a trunk port that allows VLANs 10 and 99 and also has a native VLAN of 99. And here we just have, well, we have no VLAN 20, it looks like, on switch 1, okay, or at least no VLAN 20 allowed. So I don't know that the VLAN 20s are allowed on the trunk, but it's not created within the switch. That's the issue here. So you'd have to go in and create VLAN 20 on the switch for that traffic to get from PC5 to the email server. Alright, so we have a missing VLAN 20. And so interfaces or VLANs must be allowed before they can be transmitted across, unless you have allowed everything. Okay, unless you've allowed everything. Without, if you don't do this switch port trunk allowed VLAN, then, well, all VLANs will be allowed. Alright, you can do a show interfaces trunk to ensure that the correct VLANs are permitted across the trunk, which was what we saw on the last slide. Okay. And, well, speaking of last slides, this is the last slide of this section. So I'm going to do this in a separate video, this inter VLAN routing part. We'll do the first two parts in one class session, and then we'll do the inter VLAN routing separately. So that concludes Chapter 6, Video Part 1.